Okay, we're on problem number 8. And again, I want to remind you that we just did a problem similar to this one over here. So it's really the same set of thinking. And again, some people can do this in their head. That's fine. Other people need to write that down. I'm going to write down what goes on in my head, but I do need to write that down. So I'm going to go to the whiteboard and undo the problem. So it's number 8. And let's write the problem down. I'm going to write down f of x. Again, f of x is equal to x cubed plus 6x. I'm going to write the 25 at the bottom as 5 squared. And there's going to be minus 11. And that's going to be 5 times 8. And 8 is 2 cubed. All right, so what we need to do is transform the equation into an equation that is integral coefficients, but the coefficient on the first term being 1. All right, so what do we write down? I'm going to write that down for you. So it has to be certainly some multiple of 5. So I'll put down 5m and some multiple of 2. And I'll put down 2n times f. Now, if I do that, there would be certainly a coefficient on the x cubed term, so I need to remove that. So I'm going to say I don't know what it is, but there'd be some multiple of 5. So I'm just going to put down 5. I have to use a different letter, j, and then 2 to the j. Whoops, not j. I didn't mean to do that. Different letter, right? I. Right, I'm just going to focus in, not on the letter x. I'm just going to focus on the coefficients, one at a time. So the first coefficient would be 5m times 2 to the n. And then I got to cube what's on bottom there. So it's going to be 5 to the 3j times 2 to the 3j. And the coefficient in this term, as they said, must be unity, must be 1. So what does this tell me? It tells me m must be equal to 3j, and it tells me n is equal to 3i. I did it again. I got to go back and erase it. Over here, this is not good. Okay? So n is equal to 3i. Now, why is that? I need a cancellation. I need to cancel the 1. All right, let's go to the next coefficient. And what do I see? I see a 6. I'm multiplying by 5 to the m times 2 to the n. And what goes on bottom? 5 squared times, well, it's just the bottom of the x, which would be 5j. And then it's going to be 2i. So what does this tell me? Well, things have to cancel off. So I'm going to say m must be greater than or equal to 2 plus j. And the n must be greater than or equal to I for those to cancel off. Let's go to the last guy. And what do you get there? Let's take a look at this. You can get 11 times 5 to the m times 2 to the n over 5 times 2 cubed. All right, let's take a look at this. And I got to be careful here. So the m must be greater than or equal to 1, and the n must be greater than or equal to 3. All right? Let's see if we can think through this without doing too much work. And again, this is what some students can actually do all this in their head and come up with what the m and n, j and I are. All right, let's take a look. And we're going to try to write this down now. So I'm going to say, I guess I got a restriction on the n. The n's got to be greater than or equal to 3. And the m has got to be greater than or equal to 1. So let's write this down. So I'm going to take I equal to 1. right? And let's see if that satisfies this. And I'm going to pick the j is equal to 1. Let's see if we got everything satisfied here. Well, if this were the case, what would the m be? M would be 3, and the n would be 3. All right, let's take a look at it. Certainly this is satisfied, and this is satisfied. Is this satisfied? What's m? M is 3. What's j? 1. And 3 is greater than or equal to 3. How about this one? Is n greater than I? Yes. How about this one? Is m greater than 1? Yes. How about this one? Is n greater than or equal to 3? Yes. So now I have it. So really what I need to do is go back over here and write this down. So it's going to be 5 cubed, which is 125, times n cubed, which is 8, times f of x over, let's see, it would just be 5 times, because the I and j are 1, right? That'd be 5 times 2, which is 10. All right? So what I have to do now is evaluate. Let me take a look at this. This is 1,000. Yep. Times f of x over 10. All right, I'm going to start to erase things I don't need anymore. Again, that takes time and effort to get through. Some students are very good at this, and they actually do it in their head, which I'm often amazed by. Let me start to erase things I don't need anymore. This is my thinking out loud. And again, when I'm thinking out loud, I'm really saying I have to think on paper before I can write that down. Okay, what am I going to do now? Evaluate this. So I'm going to do 1,000 times x. We're evaluating this, by the way. Put that over here. X over 10 cubed. 6 over 25 times, oh, I forgot to put the 1,000 down, times x over 10 minus 11 times 1,000 over 5 times 2 cubed. All right, let's take one term at a time. First term is x cubed plus 10 goes into 1,000 100 times, 25 goes 104 times, and you get 24. All right, let's keep going. Next one's a little bit more difficult. Let's see. 5 goes into 1,200 times. And then this goes in, let's see, that's 8 25 times. So you get 250 on 25, 275. What's the transformation that did that? 1,000 times f of x over 10. All right, let's look at the key, see if we got it. I have the correct transformation, and yeah, we got it. They don't provide a graph for that one. That's fine. You can graph it if you want. All right? Thank you for paying attention, though.